Steamboat Geyser roars to life as hundreds of quakes rattle Yellowstone. USGS stunned by mysterious subsurface movements. Yellowstone National Park tension rippled across the scientific community this week as Steamboat Geyser, the world's tallest active geyser, unleashed a spectacular and unexpectedly powerful eruption, one that coincided with a rapid-fire swarm of hundreds of micro-earthquakes pulsing beneath the surface of Yellowstone's notoriously complex hydrothermal system. According to early morning reports from the Yellowstone Volcano Observatory, YV, the geyser erupted in one of its tallest displays of the year, blasting superheated water and steam more than 250-300 feet into the air, sending a thick, ghostly plume drifting over the Norris Geyser Basin. But it wasn't the height of the eruption that shocked scientists. It was what was happening below. A sudden shiver beneath the caldera. Within minutes of the eruption, seismic instruments across north-central Yellowstone lit up with activity. What began as a few scattered rumbles quickly escalated into a dense cluster of over 300 small earthquakes within a span of just several hours. Most tremors were tiny, magnitude 0.5 to 1.5, but the pattern was unlike any swarm recorded at Steamboat in recent years. USGS volcanologists were candid. "These are strange movements. We did not expect this," one YVO geophysicist said during a Sunday briefing. The seismicity was deeper than typical hydrothermal shaking, forming tight chains and bursts that resembled rapid fluid injections or sudden pressurization shifts within the fractured rock below Norris Basin. Yet some quakes occurred even deeper, hinting at possible connections to the upper magma reservoirs that feed Yellowstone's vast system. While researchers emphasize that magma involvement is not confirmed, they admit the possibility cannot be ruled out at this stage of analysis. Eruption trigger or symptom scientists debate. Steamboat Geyser's eruptions are notorious for being unpredictable, often occurring without warning and without clear connections to earthquakes or deformation. But this time, the timing was too precise to ignore. Two theories are emerging. One pressure release triggered the swarm. The immense release of energy during Steamboat's eruption may have caused sudden depressurization in the hydrothermal system, allowing fluids to surge into new fractures, the kind of movement that produces micro-earthquakes. Too deep pressure caused both the quakes and the eruption. A competing theory suggests the opposite, that a sudden shift or injection of deep fluids caused both the seismic swarm and the geyser eruption within a short time span, meaning Steamboat was responding to deeper processes rather than initiating them. Both explanations remain under investigation. USGS deploys emergency instruments. Within hours, USGS teams and National Park Service crews began deploying portable seismometers, GPS deformation stations, and gas sampling instruments around the geyser basin. The movement of carbon dioxide, hydrogen sulfide, and helium-3 will be key to determining whether deeper magmatic fluids were involved. One scientist noted, "This is one of the most active and complex areas in Yellowstone. When something changes here, even slightly, it's worth paying close attention." The new equipment will allow researchers to detect tiny ground uplifts or drops, Gas chemistry shifts, indicating magmatic influence. Changes in geyser water temperature or mineral content. New fractures or altered hydrothermal pathways. Some fear that Steamboat's plumbing system may have undergone a significant reorganization, something that has only been seen a handful of times in the last century. A basin transformed. Rangers reported subtle yet notable changes immediately after the eruption and quake swarm. Hot springs near Norris became slightly cloudier and hotter. A few dormant vents began hissing or releasing minor steam bursts. The ground near Porcelain Basin recorded small, rapid expansions and contractions. Mudpots deepened, indicating water drainage underground. While these features often shift naturally, the timing raises questions about whether the deeper system experienced sudden stress changes. What this means for Yellowstone? USGS stresses that there is no indication of an impending volcanic eruption. Yellowstone remains at alert level green. Earthquake swarms are extremely common in the region, and Steamboat Geyser has always been a wildcard, sometimes erupting frequently for years, other times falling silent. Still, this event stands out. It's the combination of a major geyser eruption, hundreds of quakes, unusual depth patterns, immediate hydrothermal changes that make this episode worth watching carefully. One geologist summarized it best. Yellowstone isn't waking up, but something inside it definitely moved. Looking ahead, over the next several days and weeks, scientists will monitor whether the earthquake swarm continues, whether Steamboat becomes more active, whether ground deformation accelerates, whether deeper quakes begin to appear, whether other thermal features across the park show signs of pressurization. Early results from gas samples and deformation sensors should be available soon. For now, Steamboat Geyser stands quiet again, yet Yellowstone's simmering underground world is rarely calm for long.